The last thing that we're going to talk about in this section is how to tell if a pair of equations are inverses, and then how inverses and the original equations can be related to each other. Now, if we're talking about trying to decide if two functions are inverses of each other, there are two approaches. The first approach is just to pick one of the equations and find its inverse. So if I take this function and start by switching the x and y around, so I would have x equals y plus 6, and then I would subtract it, so x minus 6 equals y, and again that's my inverse, and the inverse of my y happens to equal my g of x function, so yes, these are inverses of each other, since when I found the inverse of this one, I ended up with this answer. Okay. And let me actually change this to say the name, so this is the f inverse of x, is the more correct way to say it. Okay. Now the other way, the other method that we can use to determine if two functions are inverses of each other is to do a composition. So I would do f of g of x, and I need that to equal positive x. So if I find this composition and I get this for my answer, then they are inverses of each other. If I get anything besides this, then they are not inverses of each other. So if I work through this, so this is really telling me to do f of x minus 6, and then I would have x minus 6 plus 6, which then simplifies to be x. So I ended up with that positive x for the answer. So yes, these are inverses of each other. Okay. So I would like you to go ahead and pause the video and see if you can determine if these sets are inverses of each other using either of these methods. So I personally don't care which way you determine if they're inverses, but you do need to show some type of work. And I will show both ways, so that way you guys can check your work for each of these depending on which way you do it. So the way in purple I'm doing is where I'm finding the inverse of that first equation to see if it's the same as the second. Now you could also find the inverse of the second equation to see if it's the same as the first, so that part of it doesn't matter. I'm also going to show you this by finding the composition of each one. So that's what the work in orange will represent. And then I'll go back through and kind of talk through how I got my final answer if you're a little unsure about that. Now I like to do f of g of x. You can do g of f of x. So the order that you do it in doesn't matter, but it does have to equal x. So if we're not getting that, then they are not inverses of each other. So this means to do f of 6 over x. And then if I substitute that in, this is 6 times 6 over x. So I would assume that that 6 is over 1, and then we're multiplying straight across. So this is going to be 36 over x, which does not equal x. So my answer to this would be no. Same thing, so I'm doing... So on this one, I'm actually going to do it the reverse. So g of f of x. Now again, that does not matter, and it does need to be equal to the x. So I'm doing g of x squared plus 3. So that means that I'm doing the square root of x squared plus 3. and then minus 3. Now there is absolutely no way to simplify this any further. So this definitely does not equal x. So this is also a no. Okay. Now back up on the ones in purple, because this answer wasn't exactly the same as that g of x equation. So that's what this statement is saying. So the inverse of f is not equal to g. That's how I know that these two things are not inverses of each other. Whereas on this first one, that x minus 6 is exactly the same as our g function. So the f inverse of x equals g of x. Since those are the same, then that's how I got my answer of yes. Okay. So if you are finding the inverse of one of them, that inverse has to be exactly the same as the equation that of whatever you're comparing it to. So again, I found the inverse of this one. It was not exactly the same as this, so that's why my answer is no. So more practice of that. So I want you to go ahead and pause the video, and using whichever method you prefer, I would like you to determine if each of these is an inverse of one another. Okay. I'm going to do it the composition way, but if you prefer the other method, then you can use that method instead. So your work is going to look different than mine, but you will still have the same final answer. And again, if you have not paused the video, please go ahead and do that right now and answer these yourselves. All right, so we should have gotten yes for the first two, no for that third problem. All right, so moving on to the last type of problem for this section. So as we look at 13, it is telling us that we have a one-to-one function, g and h, defined as follows. So g is a set of points, h is an equation. So for the first part, we are finding g inverse of 8. So what we'd want to do is figure out what our g of inverse is. So to do that for points, we are just flipping them around. So 8, negative 3, negative 2, 6, negative 3, 7, and 6, 8. Okay. And then since this represents an x, I'm going to find the 8x value in the inverse of g. So that is this one right here. And then whatever its y is, that is my answer. So negative 3 would be my answer for this one. Okay. Now the other way to do it without actually having to write out all of this, since we know that we are dealing with that inverse, we can also find the y value of 8 in the original, so that would be this one, and then its x would be our answer. Okay. But if it's easier for you to do this, then I would write it out the long way. Okay. So part B is telling us to find the inverse of h, so we're finding the inverse of this one. So again, why don't you guys go ahead and pause the video and figure out what the inverse of h is. Now remember, to get rid of a fraction, we just multiply by whatever that denominator is to both sides. So that h of inverse of x is going to be 7x minus 2. Okay. And then for C, we're doing a composition. And again, I know that because of that open circle. So this is really telling me to do h of the inverse h of 3. So I'm going to start with this part right here. So this is telling me that I'm going to put 3 into all the x's of the inverse of h, which we found in part B. So I'm going to plug my 3 into this. So this will be 7 times 3 minus 2. So 21 minus 2 is 19. And then now I'm going to take my 19 and plug it into the h. So then I will have 19 plus 2 over 7. So this is really 21 over 7, which is 3. So 3 is going to be my final answer for that problem. Okay. So 14 is going to be a similar process. So again, I would like you to pause the video and then go ahead and answer these 3 questions. All right, so part A is 1. And then we're finding the inverse of h. So our inverse of h is going to be negative 7x plus 9. And then for that last one, again, it's a composition, so we are evaluating. So I need to first start by substituting 2 into that inverse that I found in part B. So I'm taking negative 7 times 2 plus 9. So negative 14 plus 9 is going to be negative 5. And then I'm going to substitute that negative 5 into the h function. So that will be a negative 5 plus 9 over 7. So this is be 5 plus 9 over 14. And 14, oh, whoops, not over, sorry. Ahead of myself in my addition. Over 7, and then 14 over 7 is going to be 2. Now I want you guys to notice something. As I look at this, up here on this one, when I did the composition of a function with its inverse, that number that I plugged in was my answer. And that same thing happened on C. So that's not a coincidence, that's actually a pattern. So anytime we are doing a composition with its inverse, so whatever that happens to be, we will always get whatever that number is. Which is why when we are talking about up here, if we were determining if two things were inverses of each other, if we did the composition of them and we got that single x by itself, That's why I can say yes, that they're inverses of each other. And I know that based on this pattern right here where we're getting that number back. So if I, without even knowing what my functions are, if you were asked to do g of g inverse of 7, again, without even knowing what our g's are, my answer to this would be 7. So anytime you have something like this, or the reverse of it, so if I was doing g inverse of g of 20, my answer would be 20 for that. Okay. All right, and that is going to conclude section 2.